confused about something.
Yeah, we just went live, by the way.
Hello, everybody. How are we all doing? Is anyone in the chat yet?
Let me check. Let's see.
For those, if anyone's joining us now, welcome to the week 2 stream. Should be pretty good. We're going to wait a couple minutes before starting just to give people a chance to trickle in.
Indeed, we are.
I'm going to run and grab a glass of water just very quick. Should be 20 seconds.
Go for it. While they're doing that, hello to the 7 people currently watching. As of me looking at our Bit Project thing, feel free to say hi in chat or don't if you don't want to. It's your call. My name is Michael. I will pop out in a second here. Well, I'll stay in the call, but I'll get rid of my webcam here to let Murray give his, week 2 of lessons. Hi, Anthony. Just saw your message. And yeah, so if you have any questions or anything like that, if you're watching this on YouTube or live on YouTube, not the recording, or Twitch, feel free to just send them in the chat and I will interrupt Murray and ask him the question on your behalf.
Yes, and don't, no stupid questions either. This stuff is always, it's a little hard to get a grasp of it if you're new. So don't be afraid to ask questions that you might think are stupid, because I guarantee that we've all had questions that are stupider about this kind of stuff. So don't shy away from that. How many people are in the chat at this point?
Fluctuating. We had about half a dozen. We dropped off a little bit there.
Okay.
But I think numbers are fine. Hi to DatGameH, DatGama. Going off of Twitch names instead of your actual names from the it's Arfon. Okay, perfect.
Hello everyone, welcome back.
Whatever.
What do you think our expected turnout will be tonight? When should I get started?
I say get started at 35. That's when we're gonna get started, folks. So hang tight till then. DatGama. That's the canonical pronunciation.
Did anybody attempt the homework from last week, making your own interface? For those of us who were here last week, if not, don't worry. Does anyone work on that?
Hi to Harash in the chat on social. Samurott. Personally, I was always more of a fan of Superior, but to each their own.
Yeah, me too. I was a big Superior guy. Obviously not Embor. Like, who would go with Embor?
Embor is better than I like Embor. Embor is cool.
Embor is like gross. I don't know. Maybe I don't like pigs very much. I like Superior though. He's awesome. Here's the real question though. What's your Gen 4 starter?
Empoleon every time.
Yes. I'm there with you. Empoleon is the greatest. Everyone's always saying Chimchar, and it's just like you're just wrong. Like you were wrong.
I'm hidden abilities. Yeah, you're missing me with that. I played the card game competitively, but I never really got involved with the with the video games.
The card game was awesome. I used to get scammed on the playground with not knowing how much my cards were worth when I was in like elementary school.
I think that's like a rite of passage.
Yeah, the older kids are scamming the cards off you. But then, of course, I scammed cards off the younger kids when I was like in grade 6. So I mean, the cycle continues.
Disappointing. No, in the card game, I think of the Gen 5 starters, Embor would have been the best. I remember it had. I think that was the one that had an ability that let you attach fire energies to I think the card that you would have attached them to was at first it was a Reshiram that came out in black and white, the base set, but then when EX cards came back in, it swapped over to I think Rayquaza EX very shortly before they then swapped over to Electric instead of Embor. And no, I didn't have friends. How'd you know? It's 7:35. Let's get started.
Cool. Sounds good. So welcome to everybody who's joining us for another week of the BitCamp live sessions. Today, we're going to be going over some more basics of scripting, and we're going to do some things that make our interface and our game a little more visually appealing and make it a little more game-like. So it'll be fun. So just to recap from last week we went over a lot of different topics. We went over the basics of the interface, what all these windows do, like the hierarchy, the project window, and the inspector. We went over how to download and load in a package externally. We went over creating scripts and attaching components. And we went over the basics of manipulating the viewport and moving around within the game viewport, or the otherwise known as the scene window. So this week, we're going to jump right in, and we're going to make our game a little more appealing. So last time, we said that we can add game objects by hitting the little plus button in the hierarchy and going down to 3D object and choosing the type we want. For example, I could add a sphere by clicking sphere, and then it adds a little sphere in my game world that I can move around and attach components to. But this is a little boring, right? It's just a plain white sphere. Let's use something a little more interesting. So within the package that we imported last week, there should be a folder called Course Library. So if you click on that, you'll be presented with 4 other folders. You've got source files, ground, obstacles, sky, and vehicles. You're going to want to double click on the vehicles. And then here we've got a bunch of different vehicles. We've got a tank, a bus, 2 cars, and a van. So in your own window, if you're following along live, if not, that's okay. You don't have to follow along in the editor. But if you're doing it, pick one of these that's your favorite and drag it in. I'm going to go with the van. I like the van. So you'll notice when you drag it in and you try to put it on this plane, Unity will auto-detect that you're dragging it into a plane, and it will move this thing around on the plane as opposed to in thin air like it does when you're not moused over that. So that's a really cool feature. You can drag it in and put it down anywhere you like on the road. I'm going to put it here on the right side. If you're in Europe, you might want to put it on the left, but that's up to you. So here's our van. We've dragged this in, and now you'll notice that in the hierarchy, just like last week when we created an object, there's a new game object called van green z. So this game object is the parent of 4 other game objects, which are each of the wheels. So I can click on these individually, and as you'll notice, it highlights the wheels of the van. So there's one, there's another, and there's another. So what this means is, if you remember from last week, when we parent a game object, or we drag it onto the game object, then that one game object will follow the other's position at all times. So we can use relative positions to change where game objects are in relation to other game objects and have them follow and move with that game object. So this is actually 5 game objects wrapped into one, because each of the wheels are individual game objects, and they have a parent game object, which is the van, right? And I can actually, if I want to, I can move each of the wheels individually with the van. Like I could move this wheel out here, and then when I move the whole thing, that wheel moves with it, even though it's off the normal position. So the idea is we can use relative positions to have certain game objects follow the positions of others. I'm going to undo that because our van looks a little weird. So remember, if we want to undo, you can press Control-Z, Command-Z on Mac, or you can go into Edit and undo whatever your last move was at the top. So yeah, we've got our van here. And last week, we created a script that moves the position of a game object forward in the Z direction, so in the direction of this blue arrow, at a set speed that we define in our script. And so if you've still got that script, cool, it's right here. We can drag it in. If you don't, I'm going to open it up really quickly, and we'll review what each of the function calls and what everything in the script does. So here's our script. If you haven't made one yet, just a reminder, you can make one by clicking on your game object, going down to Add Component, typing in script in the bar here, and then it should come up with a button that says New Script. You click on that, you give your script a name, and then you hit Enter, and it should make a new script in your Assets folder that is also automatically attached to the game object you're selecting. So we've got our script from last week. And this script has two functions. Remember, this first function, start, gets called once before the first frame update of the game. So at the very start of the game. And then we've got update, which gets called every frame, right? So update gets called once per frame. And every frame, we're creating a new vector 3, which remember is just a way to store 3 numbers. In Unity, it's just 3 numbers. That's all it is, packaged into one object. So we're making a new direction vector, which is 0 in the x direction, 0 in the y direction, and 0 in the z direction. So this works in the form x, y, z, right? And each of these are coordinates. So this is the direction vector, or the vector to move in every frame. And then we call transform.translate to access our transform component that's attached to the game object and move it every frame. And then we plug in our direction vector. So that's what this script is doing. So let's attach the script to our game object by dragging it into the components. And then we will see what happens when we click play. So you see that script that we wrote last week works on this game object as well. So it's not actually specific to the sphere that we made it on last week. And that's the power of scripts and components, is that you can detach and reattach them in other places very easily. So you can move one script between game objects and it'll still work most of the time. I should say it'll still work as long as your game object has a transform component, which remember is the component that defines the position, rotation, and scale of game objects in the world space. And we'll see later that sometimes scripts won't work when we don't have the necessary components attached that the scripts access. But we'll see that in a bit. So now we've got our van moving forward. But I think our van, when I hit play, I don't know if I'm satisfied with how quickly our van is moving, right? It's going pretty slow. So what do we do if we want to speed up the van? Well, since our script is written and hard-coded here, and we define our speed using this direction vector, which we define on every update step, in order to change the speed, I'd have to go into my script, change the value, let's say 0.5 now. Then I have to save my script, go back into Unity, wait for it to recompile and load in, which might take a while sometimes. And now we're ready to hit play, and the van should move faster. Might be too fast, but there it goes, right? A little faster. But this is tedious, and I think you might be able to see how this might be tedious when you're trying to balance a game and make sure it plays well and plays in a fun and interactive way for the player. So Unity has this great system that we can use to change the speed of our car within the editor itself. Just like we can change the size of the mesh renderer, or we can change the X position by typing in a new position, let's say 7, right? Now we've changed our X position of our van, right? From inside the editor. We can do that with our scripts. So let's see how to do that. Right now, we're hard coding this 0.5 float, right? 0.5 into our direction vector. So what if instead we used a variable, right? What would that look like? Well, I can declare a variable here. Let's say a float, and it's going to be speed. And I'm going to make it equal 0.5. And we put the F at the end because that designates it as a float, floating point number. And if you're not familiar with programming, a float, all it is a number that has a decimal place, right? We don't have to get into the specifics of it, but that's all it is, number with a decimal place. And now we go down here and we can replace this value of 0.5 with speed. Okay, so that's good, right? So then it's like, this is better, because if we are using the speed in multiple different places, say if I was using the speed down here, then I wouldn't have to hard code it again here. And then if I wanted to change it, I'd have to go back and change it here and here, right? That would be kind of harder to do. So it's nice now that we have a variable that we can use in multiple places, right? So let's save this and see what this does in the engine. So we go back into Unity, we can hit play, and it's the same as before, right? It moves at the same speed. What we want is we want to be able to change the speed from within the editor so we can quickly iterate, right? There's a way to do this that's really easy. So when you declare classes, generally in programming, you usually specify where the variables in your class are accessible from, right? When I declare a variable without specifying something beforehand that tells me where I can access it, the compiler assumes that you can only access it from within this class or from with other classes in the same directory, right? Unity needs something further in order to access this. And Unity needs us to put the public keyword in front of the variable. And what this does is this will make a change in the component so we can change the speed from within the editor. So when you declare a public variable, you can modify the value from within the editor. We set a default value of 0.5. But if we change this from within the editor, as you'll see, it'll change. So now we have public in front of our variable. We're going to save, and we're going to go back into Unity. We let it recompile, figure out what it's doing. And now, when we scroll down to our script component, we've got this variable here, speed. It might be hard to see, but it's down here. It says speed, and it's by default set to 0.5. What if I want to slow it down, right? So let's see about that. Let's put 0.05, right? So now we've set that value on our game object, which has the script, which has a variable that represents its speed. And we can see it from the editor because we've put the public keyword in front of the variable in the class on our script. So now when we go back to the editor, we can change it from within. And you'll notice when we change it, it doesn't have to recompile the script. It just works and moves slower. This is a very powerful tool that sets Unity apart from some of its competitors, is that C# allows you to read in values from scripts and set them differently from the editor without getting too specific. But this is something that's very powerful about Unity that makes it good for iterating. We can set the speed like this if we declare a public variable. Are there any questions about that? That might have been a lot for those who aren't familiar with programming. But it's a very powerful tool that Unity provides. Sometimes it causes some design considerations that might not be great. For example, sometimes you don't want your variable to be accessible from the editor. Sometimes you want to keep it hidden so that it stays protected and it doesn't get changed, right? If I'm working with other people and they might not know what these variables do, then I want to keep only the ones that we might need to change accessible and the rest inaccessible, right? And the way we do that is we go in here and we get rid of the public word. Right. When it's not public, we can call it private instead. And now that means it's only accessible within this class. And so we can't access it from the Unity editor when it's private, right? So speed now is gone, right? It's nice to have stuff like this, though, accessible because we might want to iterate quickly and change the speed to balance our game, right? Okay, so let's see where we're going next. Okay, so this is cool. We've got our speed implemented from our editor. And that allows us to quickly iterate on the speed. But you might notice something, and I'm going to hit play, and let me know if you think the van is moving. Well, actually, we'll hit play, and we'll see what happens. I'm going to get you guys to focus on something. So the van is moving, but it's kind of weird because it's kind of jittering along. Like it's not moving at consistent speed, right? It's moving relative to the frame rate of the game. Does anyone know why that is? Are there any thoughts in the chat on maybe why this thing isn't moving smoothly or at a constant speed? Might be hard to see. I don't know if you guys picked that up. Are there any comments in the chat about that, Michael? I can't really see the chat. Oh, Michael, are you with us? Hello?
Oh, sorry. I think I need to add myself to the stream for you to hear me. Is that?
I can hear you now through the thing. I think you should be showing up. But
Yeah,
are there any answers to that in the chat? Has anyone figured it out? Why this thing's not moving at constant speed?
Is it because you've tied it to update in the script and that's tied to the frame rate only?
Exactly. Now that's exactly it.
That's
right?
Arfon with that suggestion.
Great point. So when we put in the update function, the update's called once per frame. But because of the way that computers are with games and how we run them, sometimes some frames take longer than others. The gap between frames sometimes is longer for any two given frames than any other two given frames. So they're not consistent, right? Sometimes we have 57 frames per second. Sometimes we have 60. Sometimes we have 58, right? Depending on your platform, it could be 29 or 30, in which case the different frame rate would make your thing move a lot slower, right? So we want to fix this. We need to find a way to tie our speed or the velocity that our van is moving at to the time of the game. I'm going to show you two different ways to do this, and both are perfectly valid. So here's the first way. There's actually another function we can use. There's lots of functions in the mono behavior class that we can use to script our entities. So let's comment this out, and we're gonna paste it somewhere else. Another function we can use called void fixed update. Fixed update is just like update in that it's called very consistently, except it's only called on a fixed time interval, right? So anything that happens here happens uniformly every couple nanoseconds. So if we put our code here instead, right, if we put my direction vector, I'm going to copy and paste it, then now our code is being called on a fixed time interval, right? So fixed update is great for things like physics calculations, where you need them to be consistent and done over a fixed time. So let's see that. Now when we hit play, you might notice it's a lot smoother, right? Or at least you've noticed, I guess it's moving slower, right? So it's moving slower, but the nice thing is that it's moving consistently, right? Because instead of getting called 60 times per second, the movement code, we're only calling it a certain number of times per second on a fixed interval. And the fixed interval is set, there's a default value of it. I'm not sure what it is exactly, but I don't think it's important to know that. I think it's just important to know that this is called on a fixed interval. So this is great. To adjust for the decreased update calls, right? It's called less frequently. It's not called 60 times per second or 58 or 57 or whatever. It's called consistently on lower time intervals. So I can increase the speed to 0.15 to compensate, and we'll get equivalent behavior, but this time our van will be being updated on a consistent basis, and so the velocity won't change, right? This is a great way. This is actually very pivotal if you're doing a lot of physics calculations and movement calculations. You want them to be happening consistently. So that's one way to do this. But let's look at another way, right? I'm going to comment this out. Oh, I can't do this. Okay, we're just going to do it manually. So I'm going to comment this out. Those who aren't familiar, comments just aren't compiled, right? The compiler ignores the comments in the code. So when we comment this out, it makes it not do anything. So let's go back to update. But what if we were able to find a way to tie our speed or our movement to the update function? And in fact, there's a really easy way to do this. So right now we're moving speed units per frame, right? Speed units per frame. That's set to 0.5 by default. So that means in one frame, I move 0.5. But sometimes there's 60 frames per second, sometimes there's 57. It's not consistent, so we want to tie this to time instead. And in fact, there's a great way to do this, which is multiply your speed by the difference in time from the last update to this update. Okay, does that make sense? Are we confused by that? That might be a tough thing to pick up. But the idea is if you can adjust your speed or the amount you move every frame by the distance between any two given calls to update or to any two given frames, then you can make consistent movement because you're adjusting for the difference in time. Okay, so at any given frame, the longer it happens, the more you move to compensate. The longer the distance between two frame calls, the longer you move to compensate, and it's proportional. So in fact, you'll get this effect where every frame you'll be moving the same distance per second instead of per frame. So the way we do this is there's a beautiful class called time. It's very aptly named. So if we take the speed and we multiply it by time dot delta time, then that will give us an adjustment for the time between the last frame call and this frame call. So this is in the time class, which is included in Unity's mono behavior scripting. The time class has a member called delta time. And every time you call delta time, it takes the current time and subtracts it from the last time you called delta time. So if I call delta time at 5 seconds, then it'll take, and the clock is at 5 seconds since I started the game, then the value will be 5 seconds. Then if I call it again at 8 seconds, right, then time.delta time will go, okay, well, the current time is 8. The last time I was called is 5. So the time between these two events is 3 seconds. It subtracts them, and then you have 3 seconds, right? So that's what this is doing, is it's adjusting our speed for the distance, or adjusting our speed for the difference in time between the last two frames where time, between now and the last frame where time.delta time was called. If this is confusing, there's great documentation on Unity's website about time and delta time and using this specifically in scripting. I highly recommend you check it out. But also feel free to ask me questions in the chat. Totally happy to answer those. So now we've adjusted for the difference between frames. We have to go back into Unity. It's going to recompile. And then we hit play, and we'll get an equivalent effect to what happened in fixed update, except now it's moving way slower. I don't even know. You might not even be able to see it moving, but it is. It's moving super, super slow, right? And that's because time.delta time between frames is sometimes 1/60th of a second, right? On average, it's 1/60th of a second. And so it's going to multiply our speed by a lot less, but it's going to be proportional, so we're moving the same amount on every frame. So now we can adjust our speed to compensate and bring our speed value up. And since we made it public earlier, we can actually just adjust it here. So if I set this up to something like 3, no, well, that's 4. Let's do 3. And then I hit play. It'll move at a better rate, but a more consistent rate. So now it's moving a lot faster, right? And we're not getting those jitters we were getting before, where it wasn't moving consistently every frame. Now it's not tied to the frame rate. It's instead tied to the system clock, which is much more accurate, right? It's almost perfectly accurate for our uses. Okay, so that's how we adjust our frame updates and our speed to happen according to the time on the system clock instead of the frame rate update, which can sometimes be lagged by things like performance and what machine you're using it on and all this kind of stuff, right? You know, when you're playing video games and the frame rate lags and you get lag. In our previous script example, we would move the same every frame regardless of lag. But now our game kind of catches up and uses the system clock instead, which is a much better solution. Cool. So our two ways to do this are we multiply by time.delta time. We multiply our speed by time.delta time. Or we can use fixed update with just the normal speed. And in both cases, we'll have to adjust the value of speed in order to make our thing work the same as it did before on normal update without this multiplication. But that's fine because we've made speed a public variable, so we can change it from within the editor down here on our script component. Cool. Are there any questions? Okay, cool. I don't think there are any questions. Feel free to interrupt me if anyone has any questions. That's what I'm here for.
We got a question.
Yeah, what's up?
It's just asked, what option would we better use?
So it really depends. It really depends. I think, so oftentimes you use update for things that don't need to be done in fixed update. And in fact, fixed update is not called every frame. It's called more separately, right? So it's like fixed update, I don't know the exact number, but it might be called at every 3 frames or every 4 frames. If I'm accepting user input, right? Like if I want to realize when the user presses W, which is done in your scripts, then I would want to use update. So sometimes I want to update my velocity based on what the user inputs, right? Most games where you control a character, you want to take an input and then adjust how the character moves, right? This is done by adjusting the vectors and things like speed. That's one way to do it. And if I want to say, like, whenever W is pressed, move the speed by 1, then I want to do this in update because then I can collect the player input on every frame, which is how I want to be doing that. Now, I also want to be doing consistent movement, so I can put that in the same function here instead of using fixed update. On the flip side of that, if I want to put in some physics calculations, which we will see in a second, some very basic ones, then I want to put those in fixed update because I want those to definitely be called every couple frames. And that is especially useful if it's not tied to my player input. So it depends, I guess. I think for now, for your purposes, as long as you're not making anything too complex, these two approaches will be equivalent. Just make sure to adjust your speed and your other values so that they're accounted for when you're updating on fixed update versus on time.delta time. I use this more often to answer your question briefly, this top one. Okay, so let's move on. We're going to play with a new component here. And here's the impetus for that. So right now, if I move my van upward, right, and I put it in the sky, right, we've got a flying van, and I hit play, what's going to happen, do you think? The van just flies. It just levitates. That's no good. That doesn't behave like a real van. What if I want my van to have gravity, right? I don't want to have to script the van so that it's constantly using gravity and like I'm scripting it manually and I'm trying to calculate the position. That's so much work. There's no point in doing that ourselves. Unity has a great tool for adding physics components or for adding physics behavior to your game objects. And that tool is called rigid body. So you can go to add component down here in rigid body and click on it. And now we've added our new component, which is our rigid body. Now this gives us a lot of different options on how our game object should behave in the game world, right? So rigid body, we have our mass, we have drag, angular drag, use gravity, yes or no, is kinematic, yes or no, interpolate, collision detection. This stuff we're not going to get into now, but make sure that you have use gravity checked off. So now when we hit play, we've got our rigid body attached. If we hit play, what's going to happen? Well, now we have gravity, right? Did you see that? Our van fell to the earth and now it's moving forward. That's really cool. But it turns out that sometimes when we're manually changing the position of the transform, it messes with, oh, okay. Sorry guys, I'm getting emails here. When we manually change the transform position, as we're doing in our script here with transform.translate, it interacts in weird ways with rigid body movement. And that's because the rigid body is trying to move the van one way, and we are trying to move it another way. And so often our manual input using scripts can mess with the rigid body's calculations behind the scenes and cause weird physics behavior that shouldn't happen. For example, sometimes you'll move through objects, or sometimes you'll collide and you'll go through something, or sometimes gravity won't affect your object the right way if you're manipulating its movement manually. And in order to see that, well, let's just do a quick example. Let's change the y that we're moving here to 0.1. So that means we're moving 0.1 units upward through our script every frame. But at the same time, our rigid body is using gravity, so it's pulling the object downward, and we're going to get some weird behavior. So let's hit play and we'll see that. So that, I guess that wasn't visible enough. So let's move that number up a bit. Let's do 1. So now our van is kind of moving up, but if we go to the scene view, look at this. You guys see that? The van moved up and then it bounced. Let's look at that again. Here, I'm going to stay on the scene view this time, and we'll be able to see the weirdness that happens when you try to script and use a rigid body at the same time. So it went up, and then it's kind of still going up, but if I go towards it, you'll see it doesn't really move naturally, right? Like and then it went down, like I'm not doing anything to it. You know, it's like messing with the calculations. So we don't want to do that. We don't want that weird behavior, right? Just like went up and then bounced and then went off to the side. That's crazy, right? That's going to cause some problems later. So we need to find a way to, when we're using physics, we need to find a way to control our character. And as it turns out, when we're using rigid body, we don't want to use transform.translate, because that will mess with our calculations, as we just saw. So we need to find a new way to move. So let's get rid of that. So rigid body, I'm going to, for example purposes, I'm going to open up a new window, and we're going to go to rigid body Unity. Oh, you can't see that, can you? There we go. We're going to go to rigid body. We're going to click on that. And Unity's got some great scripting documentation on rigid body. It's going to tell us exactly what we need to do to move our game object. So we've got a bunch of functions here, just like translate on transform, right? Earlier we went here and we saw transform at the top. That was the class or the component we're looking at. And now we're looking at rigid body. So this is going to tell us all the methods we can call to manipulate our game object from scripts. So let's see. We've got is kinematic, got use gravity, add explosion force, add force at position. So it turns out that add force is the one we're going to want to use. So for those who are familiar with physics, when something moves in the real world, we often use a force to describe the motion or to describe the momentum that we're putting onto an object. We use forces. And so Unity simulates that physical thing, like the physics that we talk about in real life, and simulates that in our games. And so rigid body is actually the class that we use to do that. So we've got that method we saw online, add force. Let's look at it again. So let's click on it. It adds a force to the rigid body. And it takes two parameters. It takes a vector 3 called force. And this force mode, which is a mode, tells us what kind of force it should enact. So we're going to ignore the mode for now, but we're going to look at this. It's a force. Takes that. It's a vector 3. And it forces the vector in the world coordinates in that direction. So let's do that. Now we've already got our vector 3, so now we just need to call it, right? But rigid bodies are funny in that, like, it's not guaranteed that our game object has a rigid body, right? We had to manually add it to the game object down here using add component, right? So first we need to collect that rigid body in our script so we can access it and then call a method on it. And here's how we're going to do that. We're going to declare a new variable called rigid body. Or it's going to be a rigid body, and we're going to call it RB. And we're going to just declare it. We're not going to initialize it. So then we're on start. We want to find that component on the game object. And this is the way I like to do this, because if we run into start and we find that there is no rigid body on the game object, then our program will fail. And now that sounds like a bad thing, but really it's what we want, because if there's no rigid body on our game object, we want it to tell us that so we can debug it, find the problem, and fix it really quickly, right? So this thing in programming, we're like, sometimes your program failing is a good thing because it tells you that something's wrong. So here's how we can get the rigid body. We're going to go RB, right, which is the variable we declared up here. We're going to assign it to get component rigid body. What this method does is it collects the component if it exists on the game object. So in fact, we added one earlier, rigid body, right? So when we attach the script to, or the script's already attached, but when we run the script, it should be able to collect this rigid body and give it to us in our variable RB of type rigid body. So that's might be a bit of programmer mumbo jumbo to those who aren't familiar, but this is what you need to do. This is one of the ways to do this in order to access your rigid body component from within a script. And that just is something you need to do. The reason it works with transform is because transform is a public property of our mono behavior. So we get transform for free. We don't need to do this for transform. But that's one of few components that we automatically get because we know that all game objects have a transform, right? In other words, all game objects have a position, a rotation, and a scale, right? So they all exist. Because if they didn't exist, what would be the point? Sorry, I shouldn't say all. There's few cases where we don't need one, but we don't really have to worry about those for the scope of this. Lesson. So now we've got our rigid body, right? We've assigned it here using get component. And now we can call this method that we looked at earlier, add force, right? So rb.add force. Oh, and what does it take? Let's look. It takes a vector 3, and it takes an optional argument, which is the mode. We're going to ignore this. We're going to use the default, so we just don't need to worry about it in our script. So because it's optional. And for our force, I'm going to change this back to 0. For our force, we're going to add my direction vector. Okay, cool. So now we've got a force being enacted on the object on a fixed time interval, which has a not on a fixed time interval, every frame, which has magnitude that is scaled to the time between the last frame and this frame. So it should work almost identically to transform.translate. But we'll run the game and we'll see if that's true. So now we've got this. Let's save it. Let's go back and let's make sure there's no errors. Oh, open up Unity. Oh, I think I got an error here. Non-invocable member rigid body cannot be used like a method. And that's on line 27. Where's that? Oh, here. Oh, here we go. I forgot this little bit. Here we go. So you got to specify the component between these little brackets. Don't worry about the syntax if you don't know. This is one of the few cases where that shows up in Unity scripting. That's just how that works for now. If you want to do more research, you can look into C#. And if you're confused about anything else, Make sure to ask me some questions. I'm here for that. And there are no dumb questions. Okay, so now we've attached our script and it compiles, and we're using rigid body to move instead of transform. So let's hit play and let's see what happens. Weird, right? We hit play and then the van is staying still. I wonder what's going on there. So let's look into it. Actually, if you'll notice, the van is moving, right? It's not staying still, it's moving. It's just that it's moving at such a slow force that the force we're applying to it is not strong enough to overcome the friction of the road, right? These physics components simulate friction as well. And since our van is on the road, we're going to experience friction. We're not going to move properly, right? Okay, so let's instead increase the magnitude of that force by increasing the speed to 8, right? Let's see if that moves it. It might not be strong enough. We'll see. No, it's still not strong enough, but it's still doing some calculations. So let's try that again. Why don't we do 30? That might be strong enough. No, okay. I might have made an error here, actually. 200, 2000, let's try that. Yeah, there we go. So now our force is strong enough, and our car is flying over there. You see it. It's just flying into oblivion. It's spinning forever. Let's turn that down to 600. Let's see about that instead. Now let's hit play. So that's interesting. And in fact, I think I've attached the script to the wrong components. So when we apply a force to the game object, its first impulse is to start rotating. So when you use this on a sphere, it's actually identical to moving it in terms of position, not in terms of rotation. So we actually instead, we want to apply my script to not the game object itself, but the wheels. And that way we can get the wheels spinning. So let's give each of the wheels their own rigid body, and let's set their mass to 0 so they don't fall off. Right? We're not going to use gravity on the wheels because our parent game object is using gravity. And let's do that for all 4 of them. This might be a bit tedious, but let's add a rigid body to all 4 of them. I'm going to set mass to 0, and we're going to get rid of gravity. Actually, we don't want mass to be 0. Keep the mass at 1. Sorry, that's my bad. Keep the mass at 1. Don't worry about fiddling with this stuff. It usually will not matter unless you're, yeah, well, it does matter, but you'll learn more about it the more you use the engine. Okay, we're going to add a rigid body to all of them. And we're going to make none of them use gravity. And then we're going to attach our script to every single one. So we can just drag it in like that. We're going to drag them in. And this is a little bit of a shady way to do this. We're going to have to change the speed in 4 different places every time. But just bear with me here. I made a mistake and an error in how I set this up. Okay, so let's try that. Now our wheels are rotating instead. And that doesn't work either. But I hope you understand the idea behind this, which is that when we apply force to a game object, we can get it to rotate. And just to show this, I'm going to make a sphere. So let's jump to that. And oh, that's not in a good position. We want to move this way over here. Let's do that. Okay. So there we go. Now our sphere is on the road. Okay, now let's apply the script to the sphere in a rigid body, and we'll see it rotate. Oh, there we go. Sphere now has a rigid body, and we're going to apply our script to it. And then when we hit play, if we look at the sphere, then we'll see the sphere. Where is it? There it is. See, rotating very, very slowly. If we increase the speed, it'll start to rotate faster, right? So what if we did like 20? Boom, there it goes, starting to accelerate. So when you have round game objects, you can apply forces to them. And this is more of not even round game objects. This is more of an exercise in how you can move game objects using physics without interrupting their gravity calculations. There's a lot of great tutorials online on how to move players like this without having them rotate and mess up like that. Yeah, that's something that I would recommend looking into for physics computations. Are there any questions about that? I know that was a little confusing near the end because the result was not what I was expecting, but I hope that sphere example demonstrates the usefulness of applying forces to game objects so that we don't interfere with their movement from a rigid body perspective. One thing I should mention, oh, are there questions, Michael?
No, sorry, I was just popping in to say there hadn't been any questions yet.
Okay, sweet. Well, I hope that means everyone understands. One thing I should mention is that when you're doing rigid body calculations, because they're physics calculations, you don't want them tied to the frame rate, right? So you want to either do what I'm doing here with speed times time dot delta time to apply a consistent force at every distance between frames. So you're applying the same force at every frame, or the same force per second at every frame. Or you can use fixed update down here. This is usually better for physics calculations, but you can use either. Okay, so let's see what else we are going over. We've looked at public variables. We've looked at fixed update. We've looked at time.delta time and covering timing aspects. We've looked at some simple physics with gravity and rigid body. And now we're going to look at camera control. So I'm going to change this script back. I'm going to get rid of the rigid body because I didn't actually get that working the way I wanted it to. So just for the purposes of example, we're going to go back to transform.translate. And we're going to get rid of the rigid body in the script. We go back to what we had earlier. I was hoping that would work out. Sorry about that. Okay, and then we're going to detach the rigid bodies from all of these. Remove. Oh, shoot, I did something wrong there. Rigid body, remove. Cool. And then wheel, rigid body, remove. This one, also remove the scripts from the wheels. That was not what I meant to do. Here we go. Oh, shoot. And let's remove that. Bear with me. Getting rid of these scripts we didn't need to add. And we're going to look in a second at a common problem that we need to fix, which is our camera controls. So this speed is too high. We're going to set this to 4. So let's make sure. Oh, we got a compile error. The name translate does not exist. Oh, we must have had a lowercase t on the translate there. So let's go fix that. Translate. I meant to go transform. Okay, so now that should be fixed. Cool. So now when we hit play, let's verify that everything's working the way it was before. Yep, we've got our levitating van here. So let's move that back down so it's not levitating as much. Cool. So now we've got our van. We have a problem. Like when we hit play, our van moves, but eventually it just moves off screen and we lose it, right? We don't have it anymore. This is a problem because how am I supposed to control a car, or how am I supposed to follow a car that I can't even see? So let's go into the camera here and let's figure out a way to have it follow the game object. So there are multiple ways of doing this. One of the ways is parenting the camera, or parenting the camera with the game object. So dragging it in so it's a sub game object of the van. So now that we've done that, the camera should move relative to the van, right? So you can see now we're moving together with the van. It's not centered exactly, so we should fix that, but that's one way to do this. We're going to see how to do this from a scripting perspective because I think it's more useful to understand that. And more importantly, what we're going to learn here is how to use data from one game object to script another one by creating our own custom camera following script. So I'm going to drag the script. I'm going to drag this camera around here. I'm going to move it behind the van, dragging it there, and I'm going to rotate it by 90 degrees. Was that the? Yeah, that's the right way we want it. So I entered a 0 in the Y rotation so that it's facing the back here. But if yours isn't in the right position, you can always just add 90 or subtract 90 from the Y rotation until it's turned in the right direction. So now we've got our camera that is behind our van. So when we click play, our van moves away and we stay here, right? It's not very good. We want to move with the van. So let's fix this. We're going to create a new component on the main camera object. We're going to go, as usual, to script, and we're going to hit new script. We call this camera movement script and hit enter. So now we've created a new script and attached it to this component. And when you go to assets in the project tab, you'll see this new script here. You can double click on it to open it in whatever text editor you're using. And now we've got our default script set up like we had before. So what we want to do is we want to, at every frame, collect the position of this game object and use it to move the camera. So let's look at that. In order to do this, we're going to declare an instance of the other game object within our game object script. So we're going to say game object, or actually what's better is to, yeah, we'll do that, game object, that'll make more sense. Game object van equals, actually we're going to leave it here. And then on void start, we're going to, well, let's look it up. Let's see what we need to do to collect a game object. So let's look at get game object unity. Game object find, here it is. So here is a method within the game object class called find. And we can type in the name as a string, which is just a series of characters, in order to find the game object by its name. So let's do that. It's a pretty simple way to do it. Could run into some problems if we're renaming things, but for now, let's just do that. Actually, no, let's. I was going to do that, but actually, this is a more interesting way to do it. So instead, let's just make our game object variable public, and you'll see why we do this in a second. So remember, when we hit public, when we put public in front of our variable, that lets us drag in a value, so we can initialize it from the editor. So now we've got van as a game object here. We're going to assign it once we get back to the editor, so we have the actual object. But right now, we're just going to assume that this is assigned to our van object when we're scripting. So in update, what we're going to do is we want to take the X position of the van, or we want to take the Z position of the van and update the camera so that it follows behind the van in the same Z position, right? So here's how we can do that. We're going to declare a integer, or we'll do a float, Z position equals van.transform.z. Oh, sorry, transform dot. I'm going to look at the API. So even if you've been working with Unity for a while, like me, you still often forget how the API works, and that's why transform Unity. That's why Google is a great tool, and specifically Unity's documentation is really great, and it tells you exactly what you need. So once we have a transform component, like we do here with van.transform, let's look up how to access the Z value. So we can access the rotation, and here, this says position, the world space position of the transform. Let's look at that. This tells us exactly what the position is, right? Okay, cool. So it's a vector 3, and with vector 3s, we can access the individual elements by using .x, .y, or .z. So when we do .z, it accesses the third value in the position, which is associated to the transform component of the van, which we will assign later. So I hope this makes sense. If the programming stuff is making you confused, don't worry, that will come with time. Basically, we're accessing the Z position of the van, right? Which is our game object here, the green one. So now we've got that in a variable. And now we want to update our camera based on the Z position of the van, right? So here's how we can do that. We can actually go to transform.translate, and this transform refers to the camera's transform, so the position of the camera, because we're going to attach this to the camera. So we can do transform.translate, new vector 3. We want to move it 0 units in the X direction, 0 units in the Y direction, and we want to move it to a new position in the Z direction. But maybe translate is not the method we want to use here, because translate moves to a new position relative to our old position, right? So we don't really want to do that. We want to just move relative to the current position of the van, which we have in a variable here. So instead of translate, actually just, this is, there's actually a better way to do this, and I'm gonna find it here. So transform, and there's a method here that sets us to an actual point in the world space. Here we go. It's going to be set position and rotation. So let's look into that. Let's see what that takes. Takes a new position, it takes a rotation. Okay, so we don't actually want to change its rotation, but we do want to change the position. We can use this method to do that. So we're going to change the position to van.transform.position, or this one before, zpos, we already made that. And we're actually going to subtract 10. So we're following 10 units behind the van. Does that make sense? We're updating the Z position to be the current Z position of the van minus 10. Well, let's actually make that more. Let's make that 20. 20 units behind the van. That's set position and rotation is the method we're using. 20 units behind, and the rotation we don't want to change. So we're actually going to plug in the current rotation, transform.rotation. Cool. So what that should do is that should keep our camera fixed but moving on the axis to follow the Z position of the van. So let's save that, and let's go in here and cross our fingers that there are no bugs. And then we hit play, and let's wait for the game to load. Oh, we actually got an error here when we compiled. Let's see. Unassigned reference exception. So the variable van of camera movement script has not been assigned. So we haven't assigned it. We've declared it as a public variable, but we haven't given it a value. And so remember, when we make a variable public, that gives us the option to change it from within the editor. So what we can do here, and this is not a great design practice, but it demonstrates the principle, is that we can drag in the game object here, and that will assign it from within the editor to the thing we want to follow, right, or our van. So now it's assigned, and let's hit play. Let's see if it works. Cool. That's pretty awesome. It's a little weird, but we're following the van, and it's kind of hard to see, but we're moving with the van. So that's awesome. Let's change the script so that we're actually not in the floor. That might make it a little more visible. So let's set the Y value. Let's set the X value to be 0, sure, and let's set the Y value to be 6. Cool. So now we go back into the editor, and we're going to be 6 units off the ground.
Hey, Murray, I'm just interrupting for a second. I got a DM on Discord from someone who is having a bit of a technical difficulties here.
Sure.
Let's see, they can't add the component myScript because the script class cannot be found. Make sure that there are no compile errors and the file name and class name match. They say they've tried everything in the book, no compile errors, names match, etc.
Okay. So the error is that the script isn't found by the. Is that what you're? What was the error again? Sorry.
The script class cannot be found.
Oh, okay. The script class cannot be found. So I think that occurs when the class you're declaring here is not recognized by the editor. You've checked that the names are the same, so that's good. But you have to make sure the name of your script is the same as your class name. And you also have to make sure that the class is in one of the folders in your project directory. So I like to keep it in assets. But you just need to make sure that when you're in Unity, you can see it, you can click on it and drag it into your component. Something else I would try, you can drag it onto your game object. I would try removing your component and adding it again. That might help. And the other thing you can do is you can take a screenshot of, which script is it, myScript or camera movement?
myScript.
myScript. Okay, take a screenshot of this if you can, print screen. Or later you can watch the recording and you can go back and make sure your code is exactly the same as what's here. And if that's not working, then I would say it might be an issue with your Unity version. So I'm using 2019.4 or 2019.3.9, but this should work on most Unity versions. I don't think that would be the issue, but make sure it's up to date, make sure it's properly installed. I don't know other than that how I could help with that.
And failing all that, we will be having office hours at some point later this week. Feel free to pop in then, and we can work on it one-on-one.
Yep, and feel free to send a message in the Discord as well if you have any questions. Until then, I'm happy to answer them, or I'm sure someone will answer you, and I'll be checking. So feel free to message there. Okay, so now we've added our camera script and we have successfully tracked the position of the van at every movement step, which is great. And you'll notice that it's very smooth movement, right? The van might be a bit jittery here, but that's because we're updating. That's actually the camera moving and kind of jittering, not the van, because it's keeping track of the object. But overall, it looks pretty good. And this is a very quick and dirty way to script it. And all I wanted to show you here is that if you want to relate game objects in your scripts, you can do this, right? You can make them a public variable and drag them in. The other thing you can do is you can use the method we looked at earlier, which is van equals game object dot find, and the name of our game object is van green z. Right? And we saw that up here in the inspector, right? So you can do that instead, and then you won't need to make this public, and you can assign it from within the script. That's an easy way to do it, and that'll cause less errors, I think, because it's not exposed. But I just wanted to show you that if you're ever having trouble and you want to quick and dirty do something like that, where you're interacting game objects, you can test it using that method. And you'll see it still works here. It just finds the game object in your hierarchy and assigns the variable that way using gameObject.find. If you're confused about any of these methods, the Unity API, once again, I can't say enough good things about it. It's super clear, it's super concise, and it tells you all of the methods you're going to need to use. And so that is super helpful. So let's see here. What else do we need to do? Okay. Yeah, one other thing I want to mention, and this is just a fun thing you can do in your editor. Is you can go here to, I keep getting emails all night. There we go. Okay, you can go to Edit. Preferences, and here you can change the color of all of your Unity interface items. So, for example, we know that the x-axis is red, the y-axis is green, and the z-axis is blue. But I could click this, and it'll pull up this color wheel, and I could make my z-axis pink, right? So let's do that. I hit Enter, and then I hit Close, and now on my little widget, the z-axis, which is usually blue, is now pink, right? If you want to, so you can change that. You can add what's called a play mode tint, which is also fun. So if you go to Preferences, you can check play mode tint. It's usually gray. If I want to change mine to bright blue, I can do that. Hit Enter, and now it's bright blue. And when I hit play, it'll tint my entire interface bright blue, right? So it's useful for folks who are colorblind and may need a bit of accessibility with the interface, so they can see it properly, or for those who just want something more readable, something that makes more sense to them. And if you want to change any of those things back to the defaults, you can go to Preferences and just click Use Defaults. And now you're back at the default editor. Okay, so that's the material for this week. Are there any questions about any of that? We went over timing concerns with rigid body, and more generally just with frame updates, so we can have smooth movement of our game objects. We talked about physics using rigid body, and I think we all learned something about how that works exactly and how to use that properly, but physics and the add force method, and why we need to use rigid body itself instead of something else to move our character while we're using physics calculations. If we use two different things, they'll mess with each other and we'll get unexpected behavior, like we saw earlier with the truck bouncing around. It's not good. We looked at the importance of and how to use public variables so we can quickly edit things and iterate fast. And we looked at camera scripting and how to parent game objects to other game objects to have the camera follow a steady moving van. And then at the end, we looked at colors of the interface and how we can adjust the interface for accessibility or just our own purposes. Okay, so are there any questions about all of that, or is that crystal clear for everybody? And obviously you don't have to ask your questions now. You can DM me on Discord, or you can just post in the Discord channel if you have any questions, or you can ask Michael your questions and he'll forward them to me or answer them himself. And that will be a great way to sort of get your questions answered. I'll do an office hours next week as well. I'm thinking noon on Monday is going to be the time I'm doing that. Noon Eastern
time. That's why I was popping in, just to give the time.
Thanks. Yeah, noon Eastern time on Monday. So if you have any questions, I will be in the Discord channel then. You can pop in and just ask me anything that you're curious about or what you want to learn more about. And that brings us to our next thing, which is the homework for this week. So this is obviously not something we're like, do the homework if you want to learn more. I'm not going to be checking submissions and well, I'm going to check the submissions and look them over and give you feedback, but I'm not going to be like on your case if you don't do it. It's for your own learning. I recommend doing it. It's very insightful. And it's good to get some hands-on practice. So here's our week 2 homework. So this Google document should be linked on the GitHub Learning Lab, right? If I'm not mistaken, it should be on there. But here it is again, just if you haven't seen it. So this week, you're going to add assets to your game and write some basic scripts to do some of the similar stuff we did in our live session today and last week. So you're going to make a race, right? So this week, we added in game objects by dragging them in from the imported assets. And you're going to be adding a couple in, and you're going to give them all different speeds using public variables, and you're going to have a race. So this is it's going to be a fun homework, I think, and it's going to teach you a lot about how game objects work and how they might or might not collide when you insert them, and how movement works in scripting. So you only need to create one script for this, and you should be able to change the velocity of the script to have 3 different values for your 3 different cars, and then put them all on the road and race. So if you have any trouble with this or it doesn't make any sense, feel free to reach out and ask questions to Michael or I, and we will get you sorted out. And that's it for this week. That's all I had to go over.
Indeed. Thanks for your help, Murray. Next week, to you guys watching at home, you're going to be meeting a new instructor for week 3. His name is Cole. He's from Thompson Rivers University. Great guy. I think you guys will have a lot of fun.
Yeah. Thanks for joining us. And it was a pleasure sort of helping you guys out, getting started with Unity. If you ever have any questions about game development or you want to just hang out, get to know each other, feel free to message me on Discord. I'm always open to DMs. Thanks, guys.
Thanks, guys. See ya.
See ya.